We've talked enough about cerebrospinal fluid. I'm not going to spend a lot of time on that. But I will point this out. If I'm looking at how cerebrospinal fluid circulates, you'll notice it circulates underneath the dura mater. Here's the arachnoid mater. This is the subdural space. So it circulates underneath the arachnoid mater. It circulates, what are these? Here and here. What are these? Ventricles, right? No, I'm talking cerebrospinal fluid now. Right in this region. Do you see this kind of dark area? It's kind of hazy. That's one of those lateral ventricles. The third ventricle is right about here. And this is the cerebral aqueduct. Nope, I'm sorry. Here's the third ventricle. Here's the fourth ventricle. So what we're seeing is we're seeing cerebrospinal fluid literally go all the way around the brain. We have these reservoirs inside, and it also passes down our spinal cord through the central canal. So let's say I've got an infection. Let's say I'm worried about an infection in my brain. How can I test it? Lumbar puncture. Because that cerebrospinal fluid will be transported all the way down. Here's another problem though. What happens if I have a blockage somewhere along this pathway? Let's say I have a blockage at the cerebral aqueduct between the third and fourth ventricles. I get pressure buildup. This fluid has to be able to circulate all the way around the brain, down through the spinal cord, and it's reabsorbed. If I have a blockage anywhere along this pathway, I start to get pressure buildup, and the pressure buildup is a real problem. Usually what happens is it will cause a collapse of blood vessels. What would a collapse of blood vessels do? Cut off. You're exactly right. Depending on whether it's in the spinal cord or the brain, if it's in the brain, it usually causes a stroke. If it's in the spinal cord, it causes paralysis. Because when we cut off blood supply, we cut off oxygen and glucose. So the problem with a blockage in cerebrospinal fluid, if the pressure builds up, here's another problem. Let's say I have a traumatic head injury. Bang, I get hit on the head with a hammer. What's the most likely thing to occur? I will have a hematoma, I'll have a blood clot. That's one thing that will occur because that blood-brain barrier is across the surface of the skull, right? And I'll also have fluid, I'll have the cerebrospinal fluid leaking out, and it's going to start to press on the brain. Again, I'm going to collapse blood vessels, and the tissue will die. So how do you correct that? You're right. You cut a piece of the skull, flip it back, and relieve the pressure. So, pressure, the whole point is cerebrospinal fluid is very prone to pressure buildup. If we get it in the wrong areas, or if we block one of these passageways, if the cerebrospinal fluid starts to build up, it creates pressure, collapses blood vessels, and kills the nervous tissue.
Which one did you say it circulated underneath?
It's circulating underneath the arachnoid mater. It's in the subdural space, or a lot of times they'll call it the subarachnoid space. Matter of fact, that's what it's labeled. See it? Subarachnoid space. It's underneath the arachnoid mater. It's between the arachnoid mater and the pia mater. Is where most of the circulation takes place. And that's true all the way down. If we're looking on the outside of the spinal cord, it also is in that subarachnoid. And here's my slides on blood-brain barrier now that I've explained it all. As I said, they're impermeable capillaries. Notice, it does allow oxygen to pass through. It also allows alcohol, nicotine, and anesthetics. So certain drugs can pass the blood-brain barrier, obviously. You go out, you drink too much, it definitely affects your cerebellum. It can get into your neural tissue. When we're looking at, let's leave that one. Here we go. If I'm looking at the spinal cord, the The bottom line is information, sensory information, is going to travel up the spinal cord on the dorsal side. You see it? This is the dorsal side of the spinal cord. The tracts on that side are carrying information up the spinal cord. Information coming back from the brain, coming down the spinal cord. I guess they've already got it on this. Are going to be on the lateral and ventral side. The red are the descending tracts. The blue are the ascending tracts. So if information's going up, it's primarily going up on the back side of the spinal cord. If information's coming back down the spinal cord, it's usually on the ventral side or the lateral side. This blue, the ascending information, sensory or motor? Sensory. What's the red? Motor. So the ascending tracts are sensory, the descending tracts are motor.